Work it, make it, do it, make sense.
Hello, everyone. Everyone here okay? Awesome. Thank you for the great music, by the way. That was awesome. Welcome to Machine Learning as an API. I'm going to tell you easy ways you can add machine intelligence to your application by accessing pre-trained machine learning models with a single API call. A bit about myself. My name is Sara Robinson. You can find me on Twitter at srobtweets. I live in New York. I'm super excited to be here in London today. I'm a developer advocate on the Google Cloud Platform team. What a developer advocate means is that I get to do a combination of building demos to teach other developers how to use Google's different developer tools, give talks at events like this, write online content like blog posts, screencasts, and technical walkthroughs. So I want to get started by talking about machine learning at a high level. So at a high level, machine learning is teaching computers to recognize patterns in the same way that our brains do. So if I show a child a picture of a cat or a dog, they'll almost instantly be able to identify which type of animal it is. It's much more difficult to teach a computer to do the same thing. So the idea here is that we want to write code that will find these patterns for us, and it'll improve over time as it's fed more examples and given more experience. So this is what a typical deep neural network looks like. This particular neural network is identifying a picture as either a cat or a dog. And we can see here that the input to the network is pixels in the image, and the output is going to be a prediction, either a cat or a dog. And throughout the different layers of the network, it's looking for features in the image. So maybe it's looking at the type of hair, the shape of the ears, the eyes, and it takes all that information and is able to output a prediction for us. This is a pretty typical neural network, but I want to take a step back for a moment and try some human-powered image detection. So if we didn't have neural networks, if we were to do this on our own, how would we go about writing the code to identify the difference between this picture of an apple or an orange? You can shout it out, the ideas, things you might look for in your algorithm. Color. Color is a great one. So we could look at the majority of the pixels in the image. If the majority of them are red, it's an apple. If the majority of them are orange, it's an orange. So that would work great for this example, but what happens if we then have grayscale images? Then we have to start all over again, writing new rules for this. So now that we have grayscale images, what's a second feature that we might want to look for? Texture. Texture is a good one. So if we look at the texture for these different fruits, we might be able to output a correct prediction. But then what happens if we add a third fruit? If we add a mango, it's going to get crazy. We're going to have to start again looking for the texture and color of this specific type of fruit. So all of these images look pretty similar. They're all types of fruits. So if we take two images that are completely different, this should be a lot easier, right? So what if we're trying to tell the difference between a picture of a dog and a mop, right? These have nothing in common. The mop is not living or breathing. It doesn't have eyes, a nose, or a mouth. Should be pretty easy to do. It's actually kind of difficult so here we have 4 pictures of dogs and mops, and it's kind of hard even for the human eye to tell the difference between these two. They look pretty similar. So the idea here is that we don't want to write specific rules to look for each of these individual things in our application. Because what if we have photos of everything, right? That's more of a common use case. So we might have all sorts of different photos, and if we're just looking to identify the difference between apples and oranges, our algorithm is not going to be very useful for other types of applications. And in addition to photos, you might have all types of unstructured data, like video, audio, and text. And this is what machine learning can help us make sense of. But why would we want to add machine learning functionality to our apps? Like, machine learning can tell us this is a picture of a cat, but why do we care? The answer is it can help us automate things that, as developers, we want to focus on the user experience of our app. We want to add awesome functionality to our applications, and we might not want to get hung up on building and training our own model to be able to identify things in our pictures. There's a lot of tools out there to help with this, so rather than reinventing the wheel, you can make use of these machine learning APIs to add interesting functionality to your applications. There's essentially 2 ways to add machine learning to your app. So on the left side, we have some tools that can help you build and train your own machine learning models using your own custom data. And this will give you a lot more room for customization. There's a bunch of open source libraries that can help you do this. And then on the right-hand side, we have machine learning as an API, which I like to call friendly machine learning. So this gives us access to pre-trained models with just one REST API request. So as long as you can send a REST request, you can make use of all of this machine learning functionality. So I'm most familiar with the Google Cloud APIs for this, so that's what I'm going to kind of walk through today when I talk about different machine learning problems. But there's lots of tools out there, so I encourage you to try out everything, find the best one for your use case. So the first problem I want to talk about that you can solve with an API is analyzing images. So using an API to do this, you can achieve pretty complex image detection with just a single REST API request. And first, before I get into how this API works, I want to talk about some problems that it can solve. So one thing that image analysis can help you do is identify text in an image, which is something you might want to do across a variety of applications. And once you get that text, you might want to do something like translate it or analyze it further. You can use image analysis to do this. Another thing you might want to do is say, is this image appropriate or not? Let's say you have an app with a lot of user-generated content, and you don't want to have somebody sitting there manually reviewing all the images saying, are they appropriate or not? You could instead do that with an API call so that you'd only have to review a small subset of those images. Another thing that can help you do is extract emotions from images. So let's say you have a lot of pictures from an event and you want to extract all the ones where people are happy to create some sort of flipbook or maybe marketing materials to tell a story about the event. You can use machine learning, specifically image analysis, to extract people's emotions from pictures. And finally, there may be some use cases where you want to verify that an image contains a certain object. Maybe you have some sort of competition, people uploading photos that have to be of a certain thing. You can use machine learning to verify that the photo does contain that specific item. So I want to talk about two companies that are using Google's Cloud Vision API, which can help you accomplish a lot of these things, just so you can get a sense of some production use cases, some companies that are using these APIs in the wild. On the left-hand side, this is an example from Disney, and they used the Cloud Vision API to promote a recent movie called Pete's Dragon, and they had a game to promote the movie where it was kind of a scavenger hunt. People were given a clue, and they had to go around and take a picture of that item, and if they got it correct, they would superimpose an image of the dragon for each one that they got correct. So the problem was they need a way to verify, does this person's user-uploaded image contain the item that they were supposed to take a picture of? And the Vision API's label detection was a good fit for that. It was able to say, yes, it contains a couch or a computer. They've solved this one correctly. And then on the right-hand side, Realtor.com used the Vision API's OCR, optical character recognition, to identify text in for sale signs. So when people were going out and looking for houses to buy, they could take a picture of the sign and it would bring up the relevant listing in the application. So just some examples of how it's being used in production. And looking specifically at the Vision API, these are some of the features that it provides. So the most basic one is label detection, which is what Disney used in the previous slide, which I was talking about. And this is essentially, what is this a picture of? It'll give you, for this image, it might say cheetah, field, animals. That's what label detection is. Face detection will tell you how many faces are in this image, where are those faces, and what are the emotions in those faces. Are they happy? Are they sad? Are they surprised or angry? Face detection can tell you that. OCR, this feature will pick out text in images. So in this sign, for example, it would be able to tell us where the text was found, what language it's in, and the actual written text itself. Explicit content detection, pretty self-explanatory. I already touched on that before, but it'll tell you, is this image appropriate or not? Landmark detection can identify common landmarks in a photo along with the latitude and longitude coordinates. And then logo detection will tell you, is there a common company logo in this image? So I just wanted to show you what the JSON response looks like. This is a selfie I took in Jordan last year with some teammates on a trip there. And this is the JSON response just for my face. So it returns a JSON object for each face found in an image. And the one for my face, you can see it has a bunch of data here. It says headwear likelihood, very unlikely, which is true. I'm not wearing a hat. But for my two teammates, it did return very likely for headwear. It can tell you if you're surprised. Here we see joy likelihood is very likely. I'm smiling in the picture. And it also tells us where different features are in the face. So left eye, right eye, nose, chin, in case we wanted to do anything with that image, like maybe draw a circle around the face or a box. And it gives you other information like, is it underexposed? Is it blurred? Lots of details on face detection. The other feature that I mentioned I wanted to show you is landmark detection. So does everyone know what this is a picture of? I'm guessing you do. So actually, I thought I did too, but this is not the Eiffel Tower. This is the Paris Hotel and Casino in Las Vegas. It's kind of a fake Eiffel Tower. So I wanted to see, would the Vision API be able to identify it? And it did correctly. It was able to identify this as the Paris Hotel and Casino with 80% confidence. So in this case, the Vision API was smarter than me because the human eye could be fooled by this image, which looks a lot like the Eiffel Tower. Some new features that were introduced in the API recently are crop hints, which gives you suggested crop dimensions for your photos. Web annotations is my favorite one. I'm going to show you a bit more about that on the next slide. This will let you search the internet for more details on what your image is. And then document text annotations is just improved OCR. So if you've got an image with a lot of text in it, like a picture of a receipt or a business card or something like that, it will be able to do a better job picking out all the words and paragraphs in that text. A little bit more detail on the web annotations feature. First thing I want to talk about is web entities, so it can find different entities in an image. I'm a big Harry Potter fan, so this is an image of not just any car, it's a car in a museum actually, and it's the car from the second Harry Potter movies. So I wanted to see what entities the Vision API was able to pull from this image. So the first thing it was able to tell me is that it is a Ford Anglia, so it was able to tell me the model of car that it was, which is true. This is what they used to fly to school in the second movie. And then it was also able to tell me that this is on display at the Art Science Museum, which is a museum in Singapore, where the exhibit is currently on display. And finally, it was also able to tell me that this is from Harry Potter, the literary series. All this just from sending the API the image, getting a bunch of data back. So these are the web entities. In addition to the entities, it gives us a lot more data on what's in the image, so it can tell us where all the URLs where this exact image exists on the internet, which is useful for things like copyright detection. If you want to see this user uploaded an image, has it already been published somewhere? This will tell you that. Partial matching images is kind of like a search by image response, so it can tell you where are similar images on the web. So maybe it would show me a car that is the same model but totally different background, things like that. And then it will tell you all the pages where the image was found. And you can all try it out in the browser, actually. If you go to cloud.google.com/vision, you can upload your images before you write any code if you want to see if it's right for your app. I'll have all the links on the last slide as well. But you can upload photos. It'll give you the full JSON response, and you can see the response for all of the different features. So that is image analysis. Oh, and in case you were wondering how it performed on these dog and mop photos, this is the response for the dog picture all the way on the right. It was 99% confident that it is a dog, and it actually was 77% confident that it's a Commodore, which is the breed of dog that this is. I may be saying that incorrectly. For the mops, it was able to identify this one, 70% confidence that it's a broom or a tool. I won't go through all of the responses, but we can see that overall it did pretty well. This third one, it didn't come out with the label dog. It said fur, so wasn't sure if that was a hit or a miss. And then on the third mop, it said textile, but not mop or broom. But overall, this is a pre-trained model, so we didn't add any custom data to it. We didn't build a model to specifically identify dogs and mops. So considering that, it did pretty well, getting about 3 out of 4 images correct for each one. So images is one type of unstructured data we want to analyze. Next, I'm going to talk about analyzing audio. So has anybody used an app on their phone that does speech-to-text transcription? Voice direction app, looks like a few hands. So what the APIs that can help you with this can basically expose that functionality to developers. So if you want to add any sort of speech-to-text transcription in your application, you can use a machine learning API to do this. So some problems that speech transcription can help your app solve is make apps more accessible. So maybe somebody that can't type into their phone instead wants to use voice direction. This could be an app to make your application more accessible for them. So along those lines, it can help connect people that might not otherwise be able to interact with your application and facilitate conversation over different mediums, audio, text, things like that. So this is an example of an app called Azar that is using Google's Speech API, and it's a chat application that has matched over 15 billion matches of people that can chat with each other. And they use the Speech API for all of the audio snippets that are sent over the app. And they also are using the translation API. So anytime, this is a good example of combining multiple machine learning APIs, which is something you might want to do in your app. So once they've transcribed the speech, let's say that the people that are matched don't speak the same language, they can use the translation API to then translate the text into the other person's host language. And the best way to show the speech API is through a demo. So I built a bash script that calls the speech API using socks, which is just a command line utility for understanding audio. So I'm going to make a live recording. I'm going to create an API request in a JSON file. We're going to send it to the speech API, and then we're going to see its response back. So I'm going to switch to the command line over here. Make sure everyone can see that. And I'm going to call my script with bash request.sh, and it's going to say press enter when you're ready to record. So I'm just going to record a 5-second audio clip. Here we go. I built a demo of the speech API using socks. And I'm going to send that to the speech API. This is what our JSON request looks like. So we tell it the encoding type, the sample rate in hertz, and we can see that it did a pretty good job. It got the acronym API. And obviously, it didn't get the tool that I used correctly, because that's the proper noun. I didn't build it using my socks. But overall, it did pretty well. It gave me 82.8% confidence. Just to look at some of the other things in the request, so we tell it the language code. If you leave this out, it will default to English, but it supports over 80 languages. So if you have a different language, you can just put the language code in your request, and it'll be able to do that for you. The speech context is a parameter you can use, which I'm going to talk about now related to this. So let's say my application has some proper nouns or specific terms that the API may not know how to transcribe correctly. I can pass it some suggestions here. So if I go into my script right here, and let's say I want it to recognize this tool that I used called socks, I can put that in the phrases parameter, and it's going to look out for that. So now if I go back to my script and record the same thing, now that it's looking for the proper noun socks, I will try it again. I built a speech API demo using socks. And we'll see how it did. Now it's looking for that phrase. I could have also tried devox. That probably would have been a good one too. And it was able to get it correctly with a little bit higher confidence. So it's just an example of how you can kind of add some of your own custom parameters for the speech API specifically to look for things that are specific to your application or use case. And it also works in a bunch of different languages. And in this example, I used batch mode. So I just sent it a complete audio file, but you can also use, it also supports streaming. So I could send it a continuous audio stream, and it would be able to transcribe that audio as the stream was coming in. So if I'm going to go back to the slides. And so that was analyzing audio. And one thing you might want to do after you analyze audio is you got the text transcription. You might want to do some further analysis on that text. And there's many different APIs that help you do this. And what they'll help you do is extract entities, sentiment, and syntax from your text so you can further analyze it. What are some reasons you might want to do this? So let's say you have a lot of people leaving reviews on your application. You might want to parse the sentiment from those reviews. So this is just a TripAdvisor page that I grabbed for a nearby restaurant. And we can see that the first review had very positive sentiment. The second review, they were happy with the gin and tonics, very happy about those, but they medium satisfaction on the food. And then the third one was a comedically bad experience. It's an angry person there. So instead of reading through all these and finding out, which ones are good and bad, if you have a lot of reviews, it might be useful to have an API that can do this for you. Another thing you might want to do is find the relationships between different words in a sentence or extract the key phrases from a sentence. So in this sentence about London, I might want to extract that it's about London and the United Kingdom, and I might want to be able to tell, what adjectives are being used to describe a specific subject in my text. That's where these types of APIs might come in handy. And one customer that's using Google's natural language API is called WooTrick. And what they are is they're a customer feedback platform. So if you've ever been on a page where you see a little survey in the bottom that says, how is your experience with this application? And you give it a rating on a scale from 0 to 10. This is what their application helps our customers do, and they help them make sense of this feedback. So the first thing that you'll do is you'll rate it from 0 to 10. That's pretty easy to parse. It's just a number. What is much more difficult to make sense of is this open-ended feedback that customers leave. And they're using the natural language API in 3 different ways to make sense of this feedback. So first, they're using sentiment analysis to say, okay, did the person's numbered rating align with the feedback they gave? So maybe they said it was a 10, but they actually had some negative feedback in their open-ended feedback. So they could use the sentiment analysis to just kind of gauge where that lined up. And then they're also using sentiment or entity and syntax annotation to pull the subjects from the feedback and route that feedback appropriately. So let's say a customer wrote in and they were very angry about usability. They could then route that by extracting that it was about usability and send it to the correct person to give them a response rather than manually having to classify that. So that's an example of how you might use this text analysis API. So I wanted to show you in a bit more detail the 3 methods of this API that you can use. The first one is entity extraction. So I just took this sentence about J.K. Rowling from her Wikipedia page, and I ran it through entity extraction. And it's able to find these 5 entities in the text. And what's interesting about the first 3 is they all actually point to the same thing. They're all different ways of referencing J.K. Rowling. The third one is a pen name she used for a different book series. And so we get, in the JSON response, we get back all of these pointing to the same thing. So we get the name of the entity, the type of the entity is person, and then we get some additional metadata about it. The MID, which is an ID that refers to J.K. Rowling in Google's knowledge graph. So if you wanted to get more information about it, you could make a call to the knowledge graph API using this ID. And we also get the Wikipedia URL if we want to get any more information on her. And then the response for the other terms looks similar. For British, we get a location, which points to the United Kingdom Wikipedia page. Again, so if you have a use case where people are referring to the same entity but in different ways, you could use the entity analysis method to kind of normalize that and make sure you are only counting the same entity once, even with different types of mentions of it. And then we get a similar response for Harry Potter. So that's the entity analysis. The second thing it can do is analyze sentiment. So in this review, the food was excellent. I would definitely go back. We get 2 pieces of data on the sentiment of this. The first is a score, which tells you overall, was this positive or negative on a scale from -1 to 1? How positive or negative is this sentence? And this one is 0.8, so it's almost fully positive. And then the magnitude tells us, regardless of being positive or negative, how strong is the sentiment in this text. This ranges from 0 to infinity. This sentence is relatively short, just 1 sentence. So we get a pretty small number for that here. And then the last thing this API can do is it can analyze syntax in text. So this part gets a little bit more into the linguistic details of the text. And here for this sentence, the natural language API helps us understand text. We get a bunch of different linguistic data on it. And this is just a visualization of the JSON response we get back. So in green, we have arrows that are telling us the relationships between the words in a sentence. This is called a dependency parse tree. And in orange, we can see the role of each word in the sentence. So API is a nominal subject. Helps is the root verb. So we get data there on, let's say we wanted to extract all the subjects from all of the sentences that are coming in. Maybe it's from customer support tickets, something like that. In purple, we have the lemma, which is just the canonical form of the word. So for helps, it is help. So if you wanted to count how many times a specific word was being used, you probably don't want to count helps and help as 2 different ones, so you can use the lemma to get the root form of the word. In red, we have the part of speech, noun, verb, adjective. And then in blue, we have additional morphology details. So is it in first or second or third person? Is it singular or plural? Is it a proper noun? Things like that. And there'll be additional details for other languages other than English here. Again, this is best shown with a demo. So for the natural language API, I built a demo where I used the Twitter streaming API to stream all the tweets. I ran this last week for 2 or 3 days, and I streamed tweets with either London, United Kingdom, or Devox in them. So I streamed these tweets. The streaming API gives you just a small subset of all the tweets about a particular topic that you're filtering on. And I sent them through the natural language API in the syntax annotation method. So I wanted to analyze the syntax of those tweets, and then I stored them in BigQuery which is essentially Google Cloud's big data as a service tool. It lets you do an analysis on really, really large data sets. So I stored them in BigQuery so that I could further analyze, what were the adjectives people used to talk about London, what were the subjects they were using, things like that. So I'm going to switch to a demo. So here's my BigQuery table, and you can see that over a couple days I collected about 140,000 tweets that either had London, United Kingdom, or Devox in them. So I can grab all the tweets with Devox. There obviously was less tweets with Devox than London or United Kingdom. But here's all the data that I'm collecting for each row in the table. So I've got the ID of the tweet, the text, the timestamp it was created, how many followers that user has. I've got the hashtags that were in the tweet. That's returned from the Twitter streaming API. And then I have this giant JSON string with the natural language API's response. And this tells us all the part of speech data. Is it a subject? Is it a noun or an adjective? So what I wanted to do was find out all the adjectives people were using to talk about London or Devox. And you're probably wondering, how on earth am I going to parse this giant JSON string with SQL? There's a feature that we can make use of called UserDefined Functions, which lets you pass a custom JavaScript function that's going to be run on all the rows in your table. So what I did here is I wrote a function to look through this JSON string and find all of the adjectives. So if I go ahead and run this, again, this is going to run this JavaScript function on all 140,000 rows in my table. Took about 5 seconds. I wasn't using cache results. And if we look here, we can see the top adjectives that were being used to describe London or United Kingdom, probably related to some news that was happening at the time. And I can do something similar. On this tab, I've written a query to extract the subject from the tweets. So let's see, I want to see what the subject was of all of those tweets and find the most common ones. So this the JavaScript function here looks similar, and I'm going to run this query on all 140,000 plus tweets, and we'll see what subjects we get. Took a little less than 8 seconds, and we can see that a lot of people referenced the tweets. Maybe they had an opinion about something, so the subject was I. That one's not super interesting. But if we scroll here, we can see some other subjects that were used in the tweets. So that's just an example of how you might use the syntax annotation method. I thought I would show an example of that since it's a little bit, might be harder to imagine how you could make use of that in your application since it gets into very nitty-gritty linguistic details. But it can really help you understand how people are thinking about a specific topic. One other thing I wanted to show you with the Natural Language API is that you can try it out on the product page here. And we just added a new feature to it that lets you do entity-based sentiment. So rather than giving you one sentiment score for an entire block of text, you can understand what the sentiment was around each entity. So if I have a sentence like, I liked the sushi, but the service was terrible, I might want it to extract sentiment for each. So here we get, for sushi, gets a score of 0.7, which from a scale of -1 to 1 is pretty positive. And then service gets -0.9, which is almost all the way negative. So that's really useful in this case where I have a couple different sentiments throughout the sentence. And so this is a case where I wouldn't want to get just one sentiment score for the entire thing. So that is the Natural Language API. And I'm going to go back to presentation mode. The next thing I want to talk about is also type of text analysis. Once you've got this text, one thing you might want to do is translate it. So you probably have users all over the world, and you want to make your application accessible to your users wherever they may be. So the Translation API can help you translate text in over 100 languages or detect the language with a single API request. Why do we need translation? Has anyone here ever used Google Translate when they travel? Most people. I find it super useful when I'm traveling. Always. Especially in countries where people don't speak a lot of English. I'll use it to talk to cab drivers or order food. Last year I was on a trip to Japan, and I really wanted to order octopus, but I was in a restaurant where nobody spoke English, so I showed the waiter Google Translate, found out the word for octopus was taco, so I was a little confused by that, but went with it and was able to get some delicious octopus. But you probably want to use it to translate more than just the word for octopus. You probably want to translate lots of things in your application. And one company that's using Google's Translation API to do this is Airbnb. And what you might not know is that 60% of the bookings occur between people that use the app in different languages. And they were able to use the Translation API to translate not only their listings, but reviews and conversations to improve a guest's likelihood to book. And they found that using the API to do this greatly improved people's experience throughout the application. Just an example of how you would call the Translation API. This is a Python code snippet. So you would just import the Google Cloud module and create a translate client. And then you just call .translate, and you pass it the text you'd like to translate and the target language that you would like to translate it to. And notice you don't need to tell it what the source language is. It will be able to detect that for you. So if all you want to do is detect the language of a text, if you've got users inputting text in a bunch of different languages, you can just detect the language without translating it. And then you can print the translated text there. One interesting thing that we added to the API recently is neural machine translation. And this is a change to the underlying model behind the translation, which greatly improves the quality. So before, with the first generation translation, the way it worked was it would translate each word in the sentence independently. So this is much the same as, let's say, if you were traveling and had a travel dictionary and you wanted to translate one sentence, you might do a word-for-word lookup. So you might look up each word and come up with a translation. And your result would probably be pretty accurate, but it might lose some of the context of the original text. And what the neural machine translation does is it looks at each word or token in the context of the surrounding sentence, and it's able to produce a much more accurate translation than before. There's a great New York Times article about it if you go to this bit.ly link, if you want to learn more about how neural machine translation works under the hood. And just to show you some how it's an improvement of the first generation translation, there's a lot of text on this slide. I'll explain it. So what I did is I took a paragraph from the original Spanish text of Harry Potter. They obviously didn't use an API to translate Harry Potter. They had somebody doing it in each of the, I believe, over 70 languages. So this is what the Spanish translator wrote, and I passed it through first generation translation and then compared it to the same translation back to English for neural machine translation. And we can see that the improved translation picks up a lot more of the nuances. So it changed from made, it changed it to manufactured, which is a much more accurate verb describing what Mr. Dursley did. And then here, if we look at the bottom, I bolded all the differences, but it changes fence of the gardens to garden fence, and then uses the correct pronoun in the last example. So small improvements, but they do make a big difference in quality of the final translation. So I built a demo of the Translation API. It's pretty self-explanatory on its own because it's translating text, but what I wanted to show you is that you can combine it with other APIs, and it can be pretty powerful. So what I did is I wrote a Python script that either takes raw text as input, or images, or audio from speech, sends those to the Natural Language API, and then translates them into a different language. So I'm going to show you a quick demo of this. I'm going to go to the command line here. And I'm going to call my Python script. And it's going to ask me, do I want to enter text, record text, or send a photo? And I'm going to start by just entering text. I'm going to say, London is one of my favorite cities. And here we can see, this is the JSON response for the first token, so just for London, from the Natural Language API. So it's identified it as a noun. Most of these things don't apply, but it is singular. It's the subject of the sentence. It ran it through sentiment analysis. Oh, that is a little hard to see on this screen. Sorry about that. The colors. So it tells us that the sentiment seems happy, and it's able to find a few entities from this, including London. So it can also pull out entities that don't have an associated Wikipedia page. So if I just wrote a sentence about myself, it would be able to pull out my name as an entity. Obviously, there would be no metadata associated with it. So I'm going to translate this. I will translate it into French. And then I've also translated, it didn't quite get that apostrophe, but I translated it back into English, and we can see that the translation is pretty accurate here. And one other thing I wanted to show you with this is how you can combine this with an image analysis API to extract text from an image, and then maybe you want to translate that text. So I have here just a picture of the Mind the Gap sign from walking around in London. And Let's see what happens when I send that to the Vision API and then to the Translation API. So I'm going to send a photo, and it's going to ask me the file path of my image, underground.jpg. And so we can see that it found the mind the gap text in the image. It's able to identify mind as a verb. It's the root verb of the sentence. It's a pretty neutral statement. And now I'm going to translate it into Japanese. And I translate it back to English because I do not speak Japanese. And it was able to do a pretty good job, locate the gap, still kind of gets the message across. Not quite the same, though. So that's just an example of how you can combine a few different machine learning APIs to do different things with text analysis in your applications. And the final type of unstructured data analysis I want to talk about today is analyzing videos. This is my favorite API to talk about. It's also the newest one that we've released. So video analysis APIs can help you understand your video's entities at shot, frame, or video level. And why would you want to do this? Let's say you have a large library of video content and you want to make it searchable. If you were to do this manually, it would take a lot of work of somebody actually going through all of your videos and writing down what was happening in every scene. So rather than doing it manually, it'd be nice if there was an API that could tell you what all of your videos are about, so then you could easily create a search from that. Another thing you might want to do is create a highlight reel. So if you're a media company and have lots of videos, you might want to say, okay, I only want my videos about this certain specific topic, and grab all the scenes from those videos. So similar to what I was saying before, normally you would have to have somebody manually going through, scrubbing the videos and finding the exact clips of what you wanted to put in the highlight reel. And then finally, it'll simplify the process of manually searching through videos, can make a large library very searchable. So I'm going to talk about Google's Video Intelligence API, which is relatively new. We launched it about 2 months ago. And this is Cantemo is a company that is using it. And what they are is they're a media asset management company. So all of their customers have a lot of video content. They're uploading their videos into the platform. Cantemo transcodes them and helps them make sense of it. And they're using the Video Intelligence API to search all of their video, to improve the user's experience searching their video content. And this API is also best experienced with a demo. So I'm going to jump to the browser. And I have a video here of a Super Bowl commercial for Google Home. I'm going to play the first couple of seconds of the video. I won't play the whole thing, but what we can see going on here is there's a bunch of scene changes throughout the video. So there's lots going on. There's a dog. There's a garage. If we were to manually look at this, we'd have to watch the whole thing and write down what was happening in each scene, and then store this in a database somewhere. With the video API, we're able to get a JSON response back that tells us in each scene what labels does it find in the video. So we can see here that it finds a dog, and it's able to tell us exactly what scene that dog is in. I found a birthday cake over here towards the end of the video. And if we scroll down, we can see all of the different labels that were returned. So it's even able to tell us that this is a dachshund. I may have pronounced that incorrectly. So it's able to tell us the specific type of dog that it is. And it's also able to identify that mountain pass from the beginning. So this is great for this is what it does for one video, but you probably, if you're using any sort of video analysis tool, you probably have a whole library of videos that you want to analyze. And the video API can help with that, because if you can see that this is the JSON response you get for one video, it makes it easy to make your entire library of videos searchable. So if I go back to my home screen, I've got quite a few videos here. And let's say that I am a media company, a sports media company, and I want to find all my videos of baseball. But I only want the baseball ones, not any other sports. So I can search my library for baseball videos, and it's able to tell me right away what are all the videos that have baseball in them. Not only is it able to say this video is about baseball, it can tell me exactly where in that video I can find a clip relevant to baseball. So this one is almost all baseball scenes. This one on the bottom actually only has one tiny clip that's relevant to baseball. And this is really useful because if we had somebody looking for that clip, they'd have to watch the entire thing, find that tiny moment. They might even skip over it if it's only lasts for maybe a second. This is the year-end search video that Google publishes at the end of every year, which gives you just the top searches from that year. So we can see if we skip ahead here. This is from 2016 when the Cubs won the World Series in Chicago. but it only lasts for that tiny moment in the video. So I'll do one more search. It's a little cold out today, so it would be nice to be on a beach right now. And while machine learning cannot take us there, it can show us all of our beach videos. So if we look here, we can find all of the different beach clips in our videos. Again, even if it's just a tiny frame in the video. So something that used to be a manual task is now super easy with a video intelligence API, which is able to analyze our video content for us with just a single API call. So I'm going to go back to the deck for a bit of wrap up. A little more detail on how this demo works. So all of the videos are stored in a Google Cloud Storage bucket, which is our object storage tool. And I use a tool called Cloud Functions, which is event-driven microservices. So I have a cloud function that's listening on my storage bucket that's going to be triggered anytime a new file is added to that bucket. So whenever a new file is added, this function is going to be called, and that function will check, is this a video file? If it is, it will send that video to the Video Intelligence API for processing. And once it's done processing, in my API request, I'm able to pass it a URL of a file in Google Cloud Storage where I can write the response. So it's going to store all of the JSON annotations in a separate bucket. And then the front end is just a Node.js app, and the front end itself doesn't call the video API. It just pulls the videos and their associated metadata. And it's able to display that and make it searchable to the user. That's a bit of how the app works. Just a quick look at what the label detection response looks like for a video. So here we have a video that's just a tour of the White House. And at this particular scene, we have a bird's eye view. It's able to identify this label. And then it tells us the start and end time of when that label appears in the video, and then the confidence of how confident it is that it found that label in this particular scene. And then here we have just a scene of a portrait. It's able to identify that this is indeed a portrait with 83% confidence. That's just what the API response looks like. And that's all I've got. So these are all of the APIs that I talked about today. If you want to learn more, feel free to head to these links. And you can actually try them out all on the product page. So what I showed you with the natural language API is actually available for all the different APIs. You can upload your own content and try them all out right there. And if you're interested in any of the demo code, I have that all in my personal GitHub repo. So it's under ML Talk demos for most of them, and then the video intelligence demo is in its own repo. And you can try them all out in the browser, as I mentioned before. And that's all I've got. Thank you for coming. Looks like we have a bit of time left. If anybody has questions, I'll be around after. Yes. The question was, how can it detect what accent you're speaking? And you're talking about the speech API, I'm guessing, right? So you can pass it the language code. I know that there's a specific language code for British English, for example. So it can't detect the language right now. But if you tell it to look out for a specific accent, then it will be able to identify that. Otherwise, it's okay at picking up accents without. Like if you have a British English accent and just give it the American English, the transcription probably wouldn't be as good. So right now you just need to tell it like the specific language code for the dialect, if there is one. Good question though. Anything else? Yes. You said, is it activated on YouTube? Like, does it support passing a YouTube URL? So the question was, does the video API support YouTube URLs? It doesn't. You need to pass it the file URL of your file in cloud storage. But that is good feedback. Anything else? The question was, if for the speech API, if you say a word that has two spellings, is that the question? How is it able to transcribe which one? I believe it looks at the context of the surrounding sentence, but that's a tricky one. So it might have a lower confidence in that case where there's a word that might be. What was your example? Vowel. Yeah, I actually don't know how it would perform in that, but if you come up after, we can try it out, find out. Socks. Yeah, so that one might be tricky because once I gave it the proper noun, it's looking out for the proper noun. So it may not understand the context if I was instead wanted to go back to talking about my socks, not the command line tool. So that might be tricky based on context. I'll be around for a bit after, so if you want to come up and ask me questions, happy to answer them. Thank you all for coming.